The curve C has this equation, and the line L has this equation where k is a constant. Show that the x-coordinate of any points of intersection of the curve C with the line L satisfy this equation here. Given that the curve C and the line L intersect at two distinct points, show that this inequality holds, and then solve this inequality. So I've summarized the question here. Let's have a quick look at it then. The curve C and the line L intersect. Well, they intersect when the y coordinates are the same. So part 1 then, here, we've got this is equal to this, and I'm going to expand the bracket in one fell swoop. 4kx minus 13k. Then I'm going to move everything over to the right hand side. So this moves over to x squared. This moves over to plus 10x. There's a 4kx here already. And then move the 4 over, becomes plus 4. And there's a minus 13k there. Already plus the 4. There's nothing on the other side now, and I've written it down from right to left. So that tells us then that x squared plus... Now there's a 2 common here. So I can write that, and I can write this term first. 2k plus 5, isn't it? 5 2s are 10. Lots of x. And then the minus can come outside the bracket. 13k. And I've got, at the moment, I need to put a minus 4 in. But I need to show that it's plus 4. So there must be a mistake here. When we moved the 4 over, it became minus 4, didn't it? So let's put that in now. Correct that error. There, and now that becomes a plus. So everything's fine. So there's the quadratic we needed to show. Given that C and L intersect at two distinct points, so part 2. So they intersect when the quadratic has real distinct roots. B squared minus 4ac must be greater than 0. So let's see what that gives. This squared is the b squared. So that times itself will give 4, 2k plus 5 squared, minus 4 times a, which is 1, times c, which is this, that makes that a plus. 13k plus 4 needs to be greater than 0. Now if you look at both these terms in this inequality, there's a 4 common, isn't there? So we can cancel that out. So that tells us then that 4k squared here, when we expand this bracket, plus 10 and 10 is 20k, plus 25, so we've expanded that bracket now, plus the 13k, plus the 4, isn't it? Needs to be greater than 0. So let's turn our attention to this problem now. So what have we got then? We've got 4k squared, plus 20 and 13k is 33k, plus 25 and 4 is 29. That's what we wanted to show. Now we need to solve this inequality. So let's have a look at this then. We need to factorize. Let's go for 4k and k and see if that works. We need a 29 and 1. It's got to be there. This gives us 4 and 29 make 33, isn't it? So that's a plus, and the plus is greater than 0. So this is a quadratic in k. The k squared is positive, so it's a U-shaped curve. It has a root at minus 1 here, and also it has a root back here, doesn't it? At minus 29 over 4. And there's our quadratic, so to speak, in k. So when is that greater than 0? So that tells us that it's greater than 0 when k will be greater than minus 1. Has to be greater than minus 1, doesn't it, for it to be greater than 0? And also, so we can put or k can be on this side, can't it? Less than minus 29 over 4.